Okay, let's look at this problem together. We're going to use the intermediate value theorem to show that the polynomial function 2x to the fourth minus 12x squared plus 2 has a real zero between negative 2 and 0. Alright, now what would this look like graphically? Let's just take an example real quick. Let's look at a specific curve or just a little curve. Now say we were checking the intermediate value theorem and we were using these two values here. Say we used x is negative 4 and we used x is equal to negative 1. Well, if we were to take that negative 4 value and plug it into our function, what we would find is we would find a positive number. Okay, if we were to take x minus 1 and plug it in, what we would find is a negative value. So because one's positive, one's negative, we can rest assured that somewhere in between these is going to be a 0. It's going to be somewhere that it crosses the x-axis. And that's all the intermediate value theorem says, is take your two numbers, plug them into your function. If one is positive and one is negative, then there must be somewhere in there between them that it crosses the x-axis. That's all that it means. Similarly, like if you were to take, I'm sorry about that. If you were to take a graph and a curve, and you were to check, let's say you checked this value here and that value there. If you plug those values into your function, what you would find is you would find two positive numbers because they're both on the upper half of the x-axis. Remember that right here all your values are positive and here all your values are negative. So notice that your two values being positive, that means that the intermediate value theorem would show that there is no 0 between those two numbers. And or that there might not be a 0. But the intermediate value theorem really only benefits us whenever we can show that one is positive and one is negative, because that definitely means, there has to be a 0 between there. Okay, so let's take and look at this particular problem, and let's work this problem here. It says to use the intermediate value theorem to show that this function has a real 0 between negative 2 and 0. So all I'm going to do is I'm going to take negative 2 and I'm going to plug it in. Okay, and that expression right there, that just means the function, and where you see an x, you're going to put in negative 2. Okay, so negative 2 to the fourth power is 16. Negative 2 squared is positive 4. 2 times 16 is 32. 12 times 4 is 48. 32 minus 48 gives me negative 16. And then we have negative 16 plus 2 is negative 14. So we see that we have a negative value. So off to the side here, I will write that. Okay, and now let's check 0. F of 0 equals all this. And again, I'm just plugging in 0. Everywhere I see an x, I'm just replacing it with 0. Okay, this becomes 0. This becomes 0. So I have positive 2. So f of 0 equals positive 2. One is positive, one is negative. Therefore, since one is positive and one's negative, that means that there must be a 0 between negative 2 and 0. Alright, I hope that helps. And so let's say we wanted to figure out where does this apply to real life? Well, what I'm going to show you is something that, yes, we could do this on a very logical basis, but this is a very basic example of how it could be used. Give me just a second. Say we wanted to figure out, is there a perfect square root between, okay, let's say if we had the question, is there a square root of 50 somewhere between 7 and 8? Okay, now what we could do is this question can actually be written as a function where you have x squared minus 50. And that is because if you were to solve that function for 0, you would have 50 equals x squared. So this is, like I said, this is a very basic idea, but this is a situation where it could be useful. So if we were to take that function and plug in 7 and 8, let's see what happens. Whenever I plug in 7, I get 49 minus 50, or negative 1. If I plug in 8, I get 64 minus 50, positive 14. Since 1 is negative, 1 is positive, we can say yes, the square root of 50 lies somewhere between 7 and 8. Okay, again, like I said, we could do this the logical way and say, well, square root of 7 squared is 49, 8 squared is 64, 50 lies between those two, so yes, there must be a square root of 50 somewhere between those two numbers. But it's just a basic idea of how you could use intermediate value theorem. And there's some other areas in physics that this value theorem is actually very important. So I hope this helps clarify a little bit.